D. 1837.50 in cm cube. Question 2. The process whereby a gaseous body loses some of its kinetic energy to a colder body is referred to as. So in this situation, the information that we have been able to collect is that it's a gaseous body, that means a gas. Then it loses its kinetic energy to a colder body. To a colder body. So a colder body. So it's like you have it, or since the colder body that you have is a liquid, the colder body that you have is definitely what? Loses its kinetic energy to a colder body. Is referred to as A. Condensation. Condensation is the process whereby gas moves to what? Liquid. B. Melting. It can never be melting because melting has to do with moving from solid to what? Liquid. That's melting. Then evaporation. Evaporation is the third one. C. Evaporation is movement from what? Liquid to gas or vapor. Then freezing. Freezing is the movement from liquid to solid. So automatically, because although the body moves from what? It loses kinetic energy, the gaseous body loses kinetic energy to move to what? And it can change to what? A colder body. But the question is, we continue to wonder, the colder body, is it a liquid or a solid? If it's a solid, you're supposed to have what? Sublimation. And if it's a liquid, you're supposed to have condensation. But since sublimation is not part of the option, then the suitable option in this regard will definitely be what? Option A, which is what? Condensation. So the process is moving from what? Gaseous body to what? To a colder body. So automatically the option that will be the correct one now is option A for question 2. Question 3. The normal boiling point of a liquid is defined as. We've been able to do that, to define that in our previous lesson. Boiling point is attained when what? The saturated vapor pressure is equal to what? External prevailing atmospheric pressure. External prevailing atmospheric pressure. That is when the boiling point is attained. So in this situation, let's see our option and see the one that will be suitable to the question. Option A, the temperature at which its vapor pressure equals to the atmospheric pressure. B, atmospheric pressure, the temperature at which the bubbles begin to form. C, the temperature at which vapor pressure equals 1 atm. That's 1 atmosphere. D, the temperature at which the rate of condensation of vapor equals the rate of vaporization of the liquid. If you look at this question very well, the option A says that the temperature at which its vapor pressure equals to the atmospheric pressure. And that is what we've been able to, the vapor pressure equals to the what? Atmospheric pressure. B says that the temperature at which the bubbles begin to form. No. C, because when you are saying that at which the bubbles begin to form. Bubbles begin to form. That means before you can observe bubbles, the vapor the boiling point would have been what? Attained. So that cannot be suitable. Then C, the temperature at which the vapor pressure equals 1 atm. Vapor pressure Vp equals to 1 atmosphere. And 1 atmosphere is the same thing as 101,325 Newton per meter. So that is not it, because is when the saturated vapor pressure equals to what? External prevailing atmospheric pressure, which can not be 1 atm. It cannot be 1 atm, because what about when you are saying 2 atm? So it cannot be so specific that that should be what? 1 atm, and that is why that option is not suitable. Then D, the temperature at which rate of condensation, the rate of condensation, that is the rate of this is when you have gas coming back to what? Liquid. That's condensation. Is equal to the rate at which the temperature with the rate of condensation of vapor equals to the rate of vaporization of liquid. So when liquid moves towards gas or vapor. So this one is simply that is when saturated vapor pressure is attained. The saturated vapor pressure is attained when the rate of condensation is equal to the what? The rate of vaporization. That is not the boiling point. So the only suitable option as far as this question is concerned will definitely be option what? Option A, which says that the temperature at which its vapor pressure equals the atmospheric pressure. Question 4. When a pressure cooker is half filled with water and heated to boiling point, then the pressure of the cooker will A, decrease, since a fraction only the water molecule has changed to vapor. B, remains constant because the total number of water molecules has not changed. C, increase because the water molecules can now reach every part of the tube. D, increase velocity leads to increase in frequency of collision of molecules with the walls of the container, hence pressure increases. If you look at this question very well, when a pressure cooker is half filled with water and heated, once it is heated, what happens? It will gain what? It will acquire kinetic energy. That's the first thing. It will acquire kinetic energy. And whenever it acquires kinetic energy, automatically there will be what? Increase in pressure. There will be what? Increase in pressure. And when increase in pressure is as a result of what? Increase in velocity. When it acquires kinetic energy, automatically there will be what? Increase in velocity. Because kinetic energy is a function or a measure of what? Velocity. When the kinetic energy increases, automatically the velocity will definitely what? Increase. That's one factor that must be borne in mind. Then, and if you look at it very well, you will see, if you look at it critically, the first one says that decrease. So decrease and disqualify option A. So there can never be anything like a decrease, because as it is heated, it will acquire kinetic energy. So automatically the velocity will not increase. So option A is nullified. Then option B remains constant. It can never remain constant, since when molecules or particles are heated, they will definitely what? Acquire kinetic energy. So automatically option B can never be suitable. Then option C, increase. Option C is very close, but there is a blemish along the line. Option C is telling us that the movement of the molecules to every part determines the increase in pressure, which is capital No. Movement of water molecules has nothing to do with what? Pressure. So option D, increase velocity, that is correct, because increase in velocity, when the particles are heated, they automatically what? They acquire kinetic energy. And since I said that kinetic energy is a measure of velocity, and velocity is definitely what? A measure of the frequency of collision. Take note of that. Is a measure of what? The frequency of collision. Because when there is increase in velocity, That means the frequency of collision between the gas particles or water molecules will definitely be what? Will increase. So in that situation, option D will say that increase in velocity leads to what? Increase in frequency of collisions of molecules with the walls of their content, and hence the velocity and the pressure increases. So automatically option D is the most suitable option in this regard. Then next question. The ratio of the initial to the final pressure of a given mass of a gas is 1:1.5. The ratio of the what? Initial is P1. Initial pressure is P1 and final pressure is what? P2. The ratio of the initial pressure to the final pressure is 1:1.5. That means P1 is 1 and P2 is 1.5. That is the establishment. Then calculate the final volume of the gas if the initial volume was 300 centimeter cube at the same temperature. So the question is asking us to calculate the final volume. What's final volume? That's V2. When the initial volume is 300 centimeter cube at the same temperature. That means the temperature T1 is equal to what? T2. That's the meaning of at the same temperature. T1 equals to T2. So we are still going to use, since T1 is equal to, so we use, since T1 equals to T2, that means they are what? Constant. Automatically, we will use Boyle's law. P1 V1 equals to what? P2 V2. Because Boyle's law is the only law that is talking about at constant what? Temperature. The volume is